Good morning, class. This is teacher Gladys, and we will be taking Form 2 Mathematics. So welcome to our show today. Feel free to text us on our numbers on the screen for any questions. And welcome for this class. I'll be taking you through indices and logarithms. And as you know, mathematics is so interactive, so I'll be expecting answers and questions from you. Anything you're not clear on, please let me know so that I can clarify that on you. So today we are talking about indices. And logarithms. Today is on day 29. So on this topic, this is a Form 2 topic, and this is one of these topics that you will not lack questions on almost in every other exam. So I would like you to be a bit attentive and have your book and pen, because as you know, in mathematics we don't have notes, but what we have is workout. So I'm sure we have very new words if it is a Form 2 student, but for the ones who are progressive, probably you know what is indices. Back in Form 1, we talked about squares and square roots. So for example, we said that if we have 2 squared, we will write it this way. And these will go down to 2 multiplied by 2. So it is 2, how many times? 1, 2. And that is where we narrow it down to 2 squared. If we have 5 squared, we will write it as 5 multiplied by 5. So it is 5, how many times? 2 times. 2 times. Back in Form 2, we have also talked about cubes and cube roots. And we said if we have 2 cubed, it will be 2 times 2 times 2. 2, how many times? 3 times. So if we have 2 raised to n, then it means that we will multiply 2 times 2 times 2 times 2, how many times? N times. Let us look at the same examples. We were talking about 2 squared. And these we narrow down to what? 2 squared, it means that we have 2 raised to 2. 5 raised to 2. 2 raised to 3. And 2 raised to n. And this means that we have a number raised to another number. So this number that is being raised to another number, so like 2 raised to 2, this is what we call our base. What about this? This we call it power. Now, in our topic, we have indices. So what does this mean? That the other name for power is called index. So the other name for power is index. When it is in plural, we call it indices. Indices. So index is in plural, it is called indices. So generally in this lesson, we shall be talking about powers. And that means we shall be talking about indices. So let us narrow down to the others. So if we have 5 squared, this means that 5 is our base, while 2 is our index. If we have 2 cubed, then it means that 2 is our power, 2 is our base, 3 is our power, and power, we have already said that it is what is called index. If we have 2 raised to n, it means that 2 is our base, while n is our index. So let us narrow this down. So if we have a number a raised to n, then this means that a is our base, while n is our index. So in this case, 2, 2, 3, n, and n is what we are calling indices. I hope I am clear on that. In our lesson today, we shall be generally talking about indices. Further, in our progressive lessons, we will talk about logarithms. But for today, welcome for us to go through indices. As I have said, when we have a raised to n, our a is the base and our n is the index. Okay, on this topic, indices, we have the laws of indices, and this makes our working out in mathematics as simpler as it can be. For example, if we have our numbers 20 raised to 5 times 20 raised to 3, this means that we shall go to 20 multiplied by 20 by 20 by 20, 1, 2, 3, 4. This is by 20, 5 times, multiplied by 20 raised to 3 times 20 raised to 3. Sorry about that. So I meant 20 times 20 times 20. These 3 times. But these will be so tiresome for us to work it out. So what we have is we narrow down to the laws of indices. And laws of indices, what it makes it easier for us to work out with numbers that have powers. Numbers, for example, in this question, when we learn about laws of indices, then it makes it simpler for us to work it out. So we shall go direct to the laws of indices, and we have 3 laws of indices. So the laws of indices, and I've said that we have 3 laws of indices. The first law, the law of multiplication. We shall derive our laws and narrow them down to the law. So, for example, if I have a raised to 3 multiplied by a raised to 2, it means that I will multiply my a how many times? 3 times. A multiplied by a by a. This is the first part. And multiplied by a multiplied by a. A 2 times. What do I get? I have this narrows down to a. How many times? 1, 2, 3, 4, 5. So this is a raised to 5. If I have 2 raised to 3 multiplied by 2 raised to 4, it means that I will be having 2, how many times? 3 times. And the other part multiplied by 2, how many times? 4 times. So it is 2 multiplied by 2 multiplied by 2 multiplied by 2. And this narrows down to what? 1, 2, how many times? 1, 2, 3, 4, 5, 6, 7. 2 raised to 7. So what if I said on both questions, this is a raised to 3 multiplied by a raised to 2. And this will be a. Remember, our bases are the same. Are you seeing we have similar bases? So I'll just say 3 plus 2. And this will give me a raised to 5. Now, can you check? Is this the same as this? Yes. So what does this mean? That simply when we have a multiplication sign and we have the bases as the same, then it means to make it easier, we can just add the index, the indices, the powers. Are you seeing that? Let us check the next question. This was 2 raised to 3. Sorry. So this is 2 raised to 3 multiplied by 2 raised to 4. And using this law, I have the same bases. So my answer becomes the base. And then I add up the index. So my indices, I add them up. 3 plus 4. What do I get? 2 raised to 7. Is it the same? Yes. So what does this mean? That for the laws of multiplication, when we are multiplying numbers that have the same bases, then we can just simply add their powers. So we narrow this down to, if we have our a raised to n multiplied by a raised to y, then it simply comes to a raised to n plus y. This is our first law of indices. And please note down these laws. They will really help. Apparently, for indices, we shall be applying the laws really much. So let us look at an example on these. Let us go back to our first question. It was 20 raised to 5 multiplied by 20 raised to 3 is equals to what? Now, can you note, do we have the same bases? Yes, and our base is 20. And we have our multiplication sign. What does this mean? That we can just simply add the powers. So our answer becomes what? Our base, which is 20. Then we add the powers. So that is 5 plus 3. So our answer becomes what? 20 raised to 8. Simple as that. But the mathematics is so simple, you just need to have the right attitude. So there we go. Let us look at another one. This one, you work it out. What if I have 2 raised to 5 multiplied by 2 raised to 8? What do you get? Let us check. Is our base the same? True, it is the same because we have our base as 2. What about, so we come and first write our base 2. What about our powers? We have a multiplication sign. Wherever you have a multiplication sign and the base is the same, we add the powers. So this is 5 plus 8. So our answer becomes 2 raised to 13. This is our answer in the simplest index form. Let us go to our law number 2. I said we have 3 laws of indices. So let's just do this. What I do, I'll be noting down the laws. So we have our first law here. And we have said if we have a raised to n multiplied by a raised to y, then we simply say that the bases are the same, a raised to n plus y. So that is the first law. The second law is the law of division. Law of division. The law of division. Remember, you can write to us for any clarifications. On our number, it is just down there, the screen. So the law of division. In the law of division, this is when we are working out numbers in power form and with division. For example, if I have 2 raised to 5 divided by 2 raised to 3, then I will narrow this down to 2 how many times? 5 times. So this is 2 multiplied by 2 multiplied by 2 multiplied by 2, 1, 2, 3, 4, multiplied by 2, divided. This is also a division sign. So divided by 2, how many times? 3. So 2 times 2 times 2. What do I get? This one goes with this goes with this goes with this. And what do I remain with? 2 times 2. What is 2 times 2? In power form, this is 2 squared. So, let us also look at another one. If we have a raised to 7 divided by a raised to 3, what shall we do? Simply, this will say that it is a how many times? 7 times. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Divided by a times a times a. What do I get? These will simply go with that. And what do I remain with? A multiplied by a by a by a. So this becomes a raised to 4. What do I want to mean? Let us look at the 2 examples. In these, we have 2 raised to 5 divided by 2 raised to 3. What if I just come, the bases are the same, remember? So I have my base, and because now it is not a multiplication sign but a division sign, what it means that I will minus my powers or my index. So 5 minus 3. What do I get? 2 raised to 5 minus 3, that is 2. Now can you check this? Is this the same as this? Right, it is the same. So this simply means that instead of going through the whole formula, then I can simplify that. When I have a division form, then I'll just minus my powers because the base is the same. Remember, I am already insisting that the base is the same. For this law to apply, as well as the multiplication law to apply, then our bases must be the same. Okay? I hope that is attractive enough for you to pass in indices. Let me check on the same as this. We have a raised to 7 divided by a raised to 3. a raised to 3. So this is division form. My bases are the same. So simply that means that I can just come and minus my powers. Simple, right? So our base is the same. And I'll have my 7 minus 3. And this will narrow down to 7 minus 3, that is 4. A raised to 4. So this is we have already derived our second law of indices. And this narrows down to that. If I have a number a raised to n divided by a raised to y, because the bases are the same, then I just minus my powers. So the base n minus y. The second law of indices. So we are writing our rows here. I add my second law, a raised to n divided by a raised to y. Then it means that I'll have my base. Sorry about this. In mathematics, we have to write it as clear as we can. So a raised to n divided by a raised to y, then this will mean it is a n minus y. That is our second law of indices. Let us check on some of the examples. If I have 5 raised to 15 divided by 5 raised to 3, then how do I work it out? Are the bases the same? Correct. Our bases are the same. They are 5. So I will have my 5 here. And because this is a division form, then we will have 15 minus 3. So I'll have 5 raised to 12. That is our answer. I hope we are getting somewhere. Let us look at the third law of indices. And we call this the law of products. Law of products. What do I mean? And this, I mean that we have two powers multiplying each other. So for example, if I have a raised to 5 what does this mean? That this is a raised to 5. How many times? 2 times. It simply comes here. And using our first law of indices, we say that if we have our bases as the same, and the power, and we just add our powers. If our bases are the same and we have a multiplication sign, it means that we will add the powers. So this will come to a 5 plus 5. And this comes to a raised to 10. Now, apparently, if I use another formula, I have a raised to 5 squared. Now, these are two powers. I can simply say that this is a. I multiply the powers 5 times 2. So this is 5 times 2. And this gives me a raised to 10. The same as this. So we have already derived our second formula, our third law of indices. And what do we say? That on our third law of indices, if we have our a raised to n then this will simply mean that we just multiply our powers. Remember, these are two powers, and that is why we are saying it is the law of product or the law of powers. So if we see anything like this, then this means it is n multiplied by y. And this is our third law of indices. There is our third law of indices. Let us look at an example on this. Work out this. Let us work out that. I'll give you a minute to work out that. Okay. So, for this question, we have 5 raised to 2, m bracket raised to another 2. According to our third law of indices, this will simply mean 5, 2 multiplied by 2 times 5 squared. We first work out this. This will come to 2 multiplied by 2 raised to 4 times 5 squared. Now let us look at that. We are supposed to leave our answer in the simplest form. We have a multiplication sign. Going back to our first law of indices, if the bases are the same and we are multiplying, we just add the powers. So this will be 5, 4 plus 2. And this comes back to 5 raised to 6, our answer. So generally, these 3 laws, they are very important when we are working with indices. Let us check on the other part of indices. So I'll give you some questions to work out on the laws of indices later as we wind up. For now, let us look at the fractional indices. Fractional indices. Fractional indices. What do I mean with fractional indices? What I mean with fractional indices is that I have indices. Remember, I said it is powers. So what I mean is simply that if I have a, then my power is in fraction form. For example, 1 over 3. This is a fraction. But remember, if I have a squared, this is not a fraction. Our index is not in fraction, so this is not a fractional indices. So I want us to look at this. If I have a raised to a third, then this means this is a fractional indices. My base is raised to an index that is a fraction. For this law, okay, for fractional indices, we try as much as possible that our fraction here is in its simplest form. So for example, if I have a raised to 2 all over 6, then what I mean is first I will write this to the simplest fraction, and this will narrow to by 2, 1, by 2, 3, a raised to a third. When we say, if I say I have a raised to 2 is equals to b, then this simply will mean that for this B, is the product of A how many times? 2 times, because this is A squared. And this will also mean that A square root, this will also mean that A is the square root of B. That if I say A square root, it is equals to, sorry about that, let's redo this. If I say I have A squared is equals to B, then this simply means that A is the square root of B. That A square root of B. For example, if I have 2 squared is equals to 4, it means that 4 is the square root of that 2 is the square root of 4. Let's sing that. So for fractional indices, I want us to look at this example. If I have 4 raised to a half multiplied by 4 raised to a half, this will simply mean that I'll have 4, because this is a multiplication form from our first law of indices. This is a half plus a half. And this gives us 4 raised to 1. So similarly, which 2 numbers that if I multiply, I'll get 4? Which 2 numbers that if I multiply them 2 times, I'll get 4? That is 2. So 2 multiplied by 2 is equals to 4, the same as this. So what does this mean? That 2 is the same as this number here. And what would that mean? That 4 raised to a half is the same as the square root of 4. I see. And if I have a fractional, remember, square root inakwanga 2 here, but we just don't show it, which is the same as here, a half. What I want to simply say is that if I have 4 raised to a half, this will also mean that I have 4 square roots. Let's check it. 8 raised to a third times 8 raised to a third times 8 raised to a third. What does this mean? That I'll have my 8 here, 1 over 3 times 1 over plus 1 over 3 plus 1 over 3, according to my first law of indices. And what I mean is that I'll have my answer, a third plus a third plus a third, that gives us 3 over 3. And that this is a whole 8. Now let us look at this. Which 3 numbers that if I multiply, I will get my 8 here, if I multiply them 3 times? This is 2, because 2 multiplied by 2 multiplied by 2, 2 times 2, 4, 4 times 2, 8. It goes back to here. So it means that 8 raised to a third is the same as 2. That is why we are saying 8 raised to a third, 8 raised to a third, 8 raised to a third. And what does it simply mean? That if I have my 8, then it is the same as the cube root of 8. And the cube root of 8 is what? It is 2. Are you seeing my others? That is why I am having a cube root here. So for fractional indices, what I simply want to mean on fractional indices is that if I have a number here, A, raised to a fractional index, 1 over y, then this will simply mean that it is A cube root of y. Are you seeing that? So you'll also note these things to note. For fractional indices, if we have A raised to 1 over y, this simply means that it is A, the root of y. The root of y. Any clarification? Please let us know. I will also want us to look at the zero index. So for example, in this question, let us look at an example. If I have 2, 25 raised to a half, what will this mean? It will mean that my base, the root of 2, and this gives us the square root of 25 is 5. That wherever you have a fractional index, then that will simply narrow down to the root of that index, the root of the base to the root of the base to that index. Let us check it. We will look at more examples as we go on the same. But for now, let us look at the zero indices. The zero indices. What does this mean? This simply means that our index or our power is 0. So, our power is 0, A raised to 0. This is what we are meaning with zero indices. Our index is 0. I want us to look at this. Consider A raised to n divided by A raised to n. What does this mean? This simply means, according to our second law of indices, that if we have our bases as the same, and we have a division sign, we simply minus our powers. So this will be A n minus n. This will n minus n, that is 0, A raised to 0. A raised to 0. Let us look at the sum. Another question. If we have 2 squared divided by 2 squared, this will mean 2. Our bases are the same, 2. So our division form, so it means we will minus the powers, 2 minus 2. And this gives us 2 raised to 0. Apparently, we also have another way to go through this. For example, in our first, we will have A raised to n divided by A raised to n. And this means that it is A times A times A n times divided by A times A times A n times. And this means that it will narrow down to 1. The same as this, 2 raised to 2 times 2 raised to 2, divided is equals to 2 times 2 divided by 2 times 2, which gives us this one 1. So what does that simply mean? That any number raised to a 0 is equals to 1. It doesn't matter how much big that number is. If I have 5 raised to 0, 1. If I have 1,000 raised to 0, 1. If I have 5,000, 50,000 raised to 0, it narrows down to 1. And this is the 0 law of index. That if we have any number, it doesn't matter how big or how small the number is, then it will narrow down to 1. So for our a raised to 0 is 1. Any number, remember when I put an a, this means it is any number. So any number raised to 0 is equals to 1. Remember I said that these will really help us when you are working, solving questions on powers or indices. So for example, if I have 2 raised to 3 multiplied by 2 raised to negative 3 is equals to what? Let us write that here. That if I have 2 raised to 3 multiplied by 2 raised to negative 3 is equals to what? Which law of indices do we use here? First, we use our first law of indices, the multiplication. Our bases are the same. So what do we do to the powers? We add the powers. So this will be 2, 3 plus negative 3. So this will be 3 plus negative 3, 2. 3 plus negative 3, that is 0. And according to our 0 index, what we have learned, that any number raised to 0 is equals to 1. So it narrows down to there. Let us look at negative indices. Negative indices. And when I say about negative indices, this will mean that my power is in negative form. For example, our a raised to negative 2, my power or my index is a negative. So this is what I mean with negative indices. And what should we know about negative indices? About negative indices, I want us to look at this. If I have x raised to 5, let us use another number. If I have y raised to 5 divided by y raised to 3, simply I'll come and say y 5 minus 3. Because it is the second law of indices. If we have the same base, we minus the powers. And this will give me y raised to 2. Similarly, if I have y raised to 3 divided by y raised to 5, this will also mean the same thing. My base is the same. So what do I come and do? I minus my powers. Y 3 minus 5. 3 minus 5 is what? 3 minus 5 is negative 2. I see. So my index is a negative index. So let us look at the same. Y, using the long formula. Using the long formula, it means that I'll have my y here multiplied 3 times divided by y multiplied how many times? 5 times. 1, 2, 3, 4, 5. So simply, I'll just come. This remains 1, so it is 1 all over y. How many times? 2 times. Is this question the same? It is the same. So it means that my y here raised to negative 2 is the same as 1 all over y squared. And this is where we are narrowing down our negative indices. Let us look still on another example. If I have 2 raised to 3 divided by 2 raised to 5, this will be 2 multiplied by 2 multiplied by 2 3 times, divided by 2 multiplied by 2 multiplied by 2 multiplied by 2 5 times. 1 2 3 4 5. We come here. So I remain, this is 1 all over 2 squared. Using the law of indices, the division law, I'll come here and say 2 raised to 3 divided by 2 raised to 5 is equals to 2, 3 minus 5. And this gives us 2 raised to negative 2. This comes back there. So for the negative indices, we say that if a number A is raised to a negative index, this will also mean that 1 all over A raised to n. Remember here it was negative, but it has turned to positive when it is a fraction. So we also note that A raised to negative n is the same as 1 all over A raised to n. Let us look at another example. That if I have 6 raised to negative a half, let us first look at a simpler one. 6 raised to negative 2, then this will simply mean that this is 1 all over 6 squared. And in the simplest form, this is 1 all over 36. So these are basically the things that we should note when we are working out with indices. The 6 things. Let us now look at what you might probably come along in your exams on the same. We look at some of the examples. Simplify. You can try and work this out back at home. C cubed times A cubed times B cubed times 4 cubed. If you are told to simplify these, let us see this C cubed. If we are told to simplify these, what is the first thing? We are working with multiplication. And as per our first law, we say if we have a multiplication, we add the powers. But remember, for those laws to apply, the 3 laws of indices, then the bases must be the same. So we first come and put the like terms together. So this will be A raised to 5 times A raised to 3 times B is alone, B raised to 3 times C raised to 3 times C raised to 3 is equals to, for the ones that have the same bases, what do? We add the powers. So this has the same bases. We come and say A 5 plus 3 multiplied by B raised to 3 multiplied by, these have the same powers. That means that we will add them. They have the same bases, sorry, and that means that we will add our powers. So we narrow down to our answer, a raised to 8 times b raised to 3 times c raised to 6. And we were told to simplify, so we give our answer in the simplest form. This will be a raised to 8, b cubed, c 6. There. Remember these, we were applying the law of multiplication where the bases are the same. Just look at another one. Two n raised to 3 Looking at that question, what do we have? We have 2n raised to 3. Remember, if here we don't have a power, that means it is 1, which we don't write. And according to our law of product, said that here this will narrow down to 2n raised to 3 times 2n raised to 5. And these, our bases are the same, so what we have is 2n 3 plus 5, which gives us 2 raised to 8. Let me look at another one that will really brainstorm our mind. I have 36 raised to a negative a half. Now, on this question, I will apply two things. I'll apply fractional indices, and I'll also apply negative indices. So first, I'll choose to use, this is 36 raised to negative a half. If I have a negative indices, it means that I can change my negative indices by putting 1 over 36 raised to a half. Now, when we are working out with fractional indices, now this is a fractional indices. I'll say, remember I said a raised to 1 over y, it is the same as the root of a of the root of y. So this will be 1 over, this will narrow down to the square root of 36. And this gives us what? 1 over the square root of 36, that is 6. Gives us our answer. So let us see about any question. Fancy, I can see you from KUTV. Repeat on numbers that have the same bases. Okay. I said that for the laws of indices to apply, then the numbers must have the same bases. So simply what I mean is that if I have 20 times 25, 20 raised to 1 times 25 raised to 2, this, it is not equal to 21 plus 2. It is not the same. Why? Because the bases are not the same. For the laws of indices to apply, then the bases must be the same. For if fancy, you can also look, if the power is 0, then we say that that narrows down to 1. Excuse me, teacher, where do we subtract or add the indices when the bases are the same, or when the signs are divisions or multiplications respectively? Okay, look at this, the laws of indices. The multiplication sign, that means we add the powers. The division form means that we minus the powers. And so this means that if I have 2 squared plus 2 raised to 3. I cannot come and say 2 plus 3. This is not right. Why? Because this is not a multiplication sign but an addition sign. The same, so if I have 2 squared minus 2 raised to 3, it cannot be 2 minus 3. Why? Because this is not a division sign. These we only apply them when the multiplication, it is multiplication or division. I hope that is clear. So I hope you have got that. So let us look at, these are some of the questions you will practice on. You can practice this back at home. If I have 20 raised to negative 3 times 25 raised to 2 by 20 raised to 3 by 25 raised to negative 4 is equals to what? You can also try this one. 2 raised to negative 6, 2 raised to 2. So you will try these ones out. You can send feedback. You can also check us on YouTube, and I'll try to answer some of those questions on YouTube as much as I can. Wherever you have our question, you'll just go there, check KUTV, check our program, our lesson today, and I'll be right there trying to answer that. You can also try, look at these. Z squared y cubed times z raised to 4 y squared all over z raised to 3 y raised to 4. Remember, as I said, these are the things that you need to check really, really well on so that you can be able to work out question on indices. So for today's lesson, we have checked out on the laws of indices. We have basically checked what is indices, tried to understand the laws of indices, the fractional indices, the zero index, and the negative indices. And we have narrowed them down to these. So remember, these are the most important things to remember on indices. If we meet again, when we meet again, I shall be talking about solving questions involving indices, where we can write whole numbers first in index in power form, that is using the prime numbers using tree factorization. And I will also be answering some of your questions that you will send to me. I mean, all of your questions that you will send to us. So it was good having you in my class. Remember to check us out every day. We'll be having our lessons. Thank you and have a nice day.